Good afternoon, class. We are looking at chapter 1 functions. Here's 1.5 transformational functions and 1.6 absolute value functions. So in these two sections, so we've covered a bunch of sections, and in these two sections, we are covering the following objectives: graph functions using vertical and horizontal shifts, graph functions using reflection about the x and y axis, determine whether a function is even or odd, graph functions using compression and stretches, combine transformations, graph an absolute value function, so an absolute value equation. We want to have an idea how to do that. Of course, when it gets involved, you can always use graphing calculator, but recall composition of functions. First of all, algebra of functions. F plus g is f of x plus g of x, f minus g is f of x minus g of x, f times g is f of x times g of x, and f over g is f of x over g of x. The sum function, the difference function, the product function, the quotient function. Needless to say, g can't be zero here. When you look at 2 points on a graph, you connect them, you create a line, the name is a secant line. And to find the slope of the secant line, you can look at it from a different point of view. If this is A, this is B, you can go with f of A minus f of B, f of B minus f of A over B minus A. If you call this x, then would be f of x minus f of A over x minus A. If you call this distance h, then would be f of A plus h minus f of A over h, all of which are rise over 1. The domain of f is A, domain of g is B in the case of functions that are given here. For all of these functions, algebra functions, A intersection B is the domain because they both have to be defined. However, there's more restriction for this last one. As always, we can't have denominator to be 0. So the last one, f over g, it's not only that x is an element of, this is read an element of A intersection B such that g of x can't be 0. So an element of such that, let me just write that. This looks like an epsilon. An element of, and this line segment is such that. And for a composite function, x is the domain of g, and f is the, and g is the domain of f, so f of g of x or f of g of x. Composite function, f of g is f of g of x, g of f is g of f of x. They're not the same, by the way, in general, unless they're inverse functions. And in that case, the domain g must be defined. So if you're looking at this one, so any x not in the domain of g must be excluded. Also, f of g of x must be defined. So any x for which g of x is not in the domain of f must be excluded. You can look at the recordings of what we have done. Also, as far as the graphs, because we're going to need them here, reminding you that it's a constant function. A domain is all real numbers, but range is just 1 point, namely B. Identity function, y or f of x equals x, domain and range are all real numbers. Square function, y equals x squared. It's a parabola where domain is all real numbers, but range is from 0 to infinity. F of x equals x cubed, the cube function, the domain is all real numbers as well as the range. When we look at the root functions, we have f of x equals square root of x. Domain and range go from 0 to infinity for x, same thing for y. So 0 to infinity, whereas cube root of x, there is no restriction. The graph looks like that, and the domain is all real numbers as well as the range. A reciprocal function is a rational function. So the domain and range, they have a restriction. 0 is not part of it. Therefore, the domain is all real numbers except 0. So is the range. And this is the interval notation to represent that. So that's the summary. Now, graphing techniques, transformations, we're going to touch upon that, making sure we know the concept, okay? Vertical and horizontal shifts or translation, when we are assuming C is a number which is positive, that makes it easier to understand the concept. By applying certain transformations to the graph of a given function, we can obtain the graphs of related functions. For example, here's f of x, shifted up by C units, f of x plus C, down by C units, f of x minus C. Shifted to the right, f of x minus C, shifted to the left, f of x minus C. Y equals f of x plus C is just a graph of y equals f of x, shifted up by C units, f of x minus C, shifted down by C units. Y equals g of x equals f of x minus C is just a graph of y equals f of x, shifted right by C units. The value of g at x is the same as the value of f at x minus C, so C units to the left of x. Therefore, the graph of y equals f of x minus C is just graph of y equals f of x shifted C units to the right. So left and right accordingly. And so y equals f of x plus C is just a graph of y equals f of x shifted left by C units. All right, graph functions using vertical and horizontal shifts where f of x is given as x squared. So in order to graph this, we notice that y for f of x equals x squared is the basic function. It's a parabola. And then we pick a few points and we plot those just to show you how that works. So for example, for -3, for x squared, we get +9, +4, +1, 0, 1, 4, 3. And for x squared plus 3, the same numbers that we have here, we're going to add 3 to all of those. So this becomes 9 plus 3, 4 plus 3, and so on. So if we were to plot those pairs, for example, 1, 1, now it's 1, 4, just to give you an idea. 0, 0, it's now 0, 3. So it's been shifted up by 3 units. So every point is the same, but shifted up by 3 units. So that shows that it moves up by 3 units. Domain is the same for both of them, is all real numbers. Range for this one was from 0 to infinity, but this one, the range has changed because we've gone up 3 units. So it's from 3 to infinity. So this is the change that you got to pay attention to. Domain doesn't change, range does. What about this one? Again, let's write the first 2 columns and then subtract 4. So these 2 columns from here, we are repeating it. Now -4, that means x squared minus 4. So we're going to subtract 4. This becomes 5, 0, -3, -4, and so on. So subtract 4. So in essence, for example, 0, 0 has a location 0, -4 down here. So if you look at a bunch of them, 0, 0, 0, -4, two, 4 is now 2, 0. -2, 4 is now -2, 0. Those 3 points are good enough to show us it's the same graph shifted down. As a result, the domain doesn't change. But the range now is from the y coordinate of this point, -4 to infinity. So domain doesn't change, but range does. Graph functions using vertical and horizontal shifts. Use the graph of y or f of x equals square root of x to obtain the graph of g of x equals square root of x minus 2, h of x equals square root of x plus 4. So, of course, we know the basic graph of square root of x. And let's go with easy numbers, everybody. The reason we go with 0 because square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, 16 is 4, 25 is 5. So we know those. We don't need a calculator. So these are the answers for x and square root of x. Okay. Now, if we want to go with this one, square root of x minus 2, if I want to get to the same answer here, I have to choose 2. If I choose 2, I get to the same y coordinate. Over here, if I choose this number, add 2. If I choose 3, I get the same number. This one, if I choose to 6, I get the same number. So this y coordinates, we want them to be identical to the y coordinates here. How do we work on the x coordinates? If you want 0 here, 2 must be, x must be 2. If you want 1, x must be 3. If you want 2, x minus 2 must be 4. That means x must be 6, and so on. So the question is, for the same value as square root of x, or square root of x minus 2, what should x be? And we just use the same x coordinates, but this is negative 2, so we add 2. In other words, we shift it to the right. So notice 0, 0 here corresponds to 2, 0 here as we shift it to the right. 1, 1 corresponds to 3, 1 or 6, 2. Okay. 4, 2 corresponds to 6, 2. You can pick up a couple more. So what happens is that this one, the domain and range was from 0 to infinity. The blue one, the range doesn't change, but the domain is now from 2 to infinity. So the change is on the domain. Okay. So that's for part A. What happens to part B? Notice what we want. We want the same y coordinates here. 0, 1, 2, 3, 4, 5, 6. So compared to this one, we are comparing it to the basic one, to the elementary function, remember? But those one of those essential functions. So how do I get 0 here? If this is 0, so x must be minus 4. So I get negative 4 here. How do I get 1 here if I get negative 3 here? How do I get 2 here if I get 0 here? How do I get 3 here? Remember what you want. You want 9, right? Because square root of 9 is 3. So you need 5 here. And so on. So for the same value as square root of x, for square root of x plus 4, what should x be? That is the question. So these are the ones. And so we notice we are using the same thing, but we are subtracting. So same values here. Subtract for example, 36 minus 4 is 32. 25 minus 4 is 21. So you're shifting to the left by 4 units. So this basic elementary function shifts to the left. And so what happens is that 0, 0 becomes minus 4, 0. Or 2 becomes 0, 2. So what is the result? The domain has changed now from 0 to infinity for the basic one to -4 to infinity, but the range doesn't change. So domain from -4 to infinity, the range doesn't change from 0 to infinity. Use the graph of f of x equals x squared as an essential or elementary function to obtain the following graph and state its domain and range. G of x is x plus 3 quantity squared minus 5. So obviously we're going to start with this one. Now we're going to replace the x with x plus 3. That means we are moving it to the left by 3 units. Move 3 units to the left. Looks like that. So for example, 0, 0 becomes minus 3, 0. 1, 1 becomes -2, 1. -1, 1. Subtract 3 here, you get minus 4. Now with this -5, we are going to move it down by 5 units. Bring this down by 5 units. For example, 0, 0. It's now -3, 0. And over here, we bring it down, becomes -3, comma, -5, just as an example. So subtract 5 from the y coordinates of these 3 points, just as an example. 1 minus 5 is -4. Okay. And this is minus 3 minus 5. So what is the effect? The domain doesn't change. The domain in all of them is all real numbers. What about the range? The range is the same for these two, but this one, it has shifted down by 5 units. So the range is from -5 to infinity. So the domain hasn't changed, but the range has. And you can see it from the graph, easily from the graph, everybody. Use the graph of f of x equals absolute value of x to obtain the following graph and state its domain and range. G of x absolute value of x plus 3 minus 5. The transformation on absolute value is really the same as a parabola, if you will, in the same manner that this shifts to the left by 3 units and this shifts down by 5 units. So first and foremost, this is the basic V-shape absolute value graph. Oh, okay, so it's one of those elementary functions. First, with this plus 3, we are going to shift it to the left by 3 units. And so when we do that, for example, this one becomes minus 3. So all the x coordinates, subtract 3. So this becomes -5, 2. This becomes -1, 2. This becomes -3, 0. And those 3 points are good enough for you to give you the graph. So this is y equals absolute value of x. This is y equals absolute value of x plus 3. And now we're going to do -5. That means we are going to shift this one down by 5 units. That means all of these keep the x coordinates, subtract 5 from the y coordinates. So this becomes minus 5. 2 minus 5 is negative 3. This is minus 5. Minus 1. 2 minus 5 is negative 3. And there you have it. So it's been shifted down by 5 units. The effect is all of them have the same domain, everybody. Domain is not changing. But the range does, because the range is 0 to infinity in those two cases, but this one comes down to negative 5. So from negative 5 up, so the range is from negative 5 to infinity. We're going to continue with the transformation, compression, stretches, reflection, and we are assuming, again, we are dealing with a number c that is larger than 1. So y equals c times f of x is the graph of y equals f of x stretched by a factor of c in the vertical direction, because each y coordinate is multiplied by the same numbers. So this is f of x, c is larger than 1, so it makes it larger. The y coordinates, this one 1 over c makes it smaller. Minus f of x, that is translation, that means reflection with respect to the x-axis, because you're changing the y from positive to negative, for example. If you look at f of minus x and you change the x to minus x, reflection with respect to the y-axis. So 1 over c f of x is the graph of y equals f of x shrunk by a factor of c in the vertical direction, because each y coordinate divided by the same number. Y equals fc of x is the graph of y equals f of x shrunk by a factor of c in a horizontal direction, because each x coordinate is divided by the same number c. This one is normally easy to understand when we look at sinusoidal functions. Y equals f of x over c is the graph, the same thing, is the graph of y equals f of x stretched by a factor of c in the horizontal direction, because each x coordinate is multiplied by the same number c. And y equals minus f of x is the graph of y equals f of x reflected about the x-axis, because the point x comma y is replaced by the point x comma negative y. And finally, y equals f of minus x is the graph of y equals f of x reflected about the y-axis, because the point x comma y is replaced by the point negative x comma y. So let's make some sense out of this by looking at a couple of examples. The graph of y equals f of x is given. It's a sinusoidal function. In fact, it's y equals sine x. I use it to obtain the graph of y equals 2 times f of x. 2 times f of x. So f of x, the y coordinate, is being stretched by a factor of 2 in a vertical direction. So when you look at these points, this is pi over 2 comma 1, and the result is becomes pi over 2 comma 2. This one 5 pi over 2 comma 2. This one 3 pi over 2 comma negative 2. So this goes up in essence 2 times. Whatever the y coordinate is, 2 times of that. And it looks like that. Okay, so it becomes, you want to use the same set of axes. Something like that for this. Okay. Y equals 3 f of 3x. Now, it is shrunk by a factor of 3 in the horizontal direction. What does it mean? I want to make sure we understand that one. So basically, when you look at this one, let me erase that. I want you to notice this sinusoidal function, and you stop here as a complete cycle. If you look at this part, and then we will look at this 2 pi in essence gets divided by this number, 3. Okay, so it has an effect in the period of the function. We'll discuss it further in the trigonometry. So every point that you have, the y coordinate remains unchanged. The x coordinate gets divided by 3. So if I divide this one by 3, I get pi over 6, comma 1. If I divide this one by 3, I get pi over 2, comma negative 1. If I divide this one, I get by 3, I get 5 pi over 6, comma 1. So take a look at this one. So it shrinks this way, okay, along the x-axis by a factor of 3. If it were 1/3, it would go that way. It would stretch along the x-axis. So a recap. When you have a number in front of a function, you multiply the y coordinate by that number. It doesn't matter if it's 2 times 2, if it's 10 times 10, if it's 1/2 times 1/2. But you don't touch the x coordinates. Same x coordinates, the y coordinates are affected. But in this case, the same y coordinates you don't touch. You change the x coordinates as follows. Whatever this number is, you divide the x coordinate by it. So for example, if it's 3, you divide by 3. But if it's 1/3, you multiply. Division by 1/3 means multiplication by 3. Graph and find the domain and range of this function. First and foremost, we remember y equals f of x. And we have those. So when we say minus x squared, all of this y coordinates, so this, we have done that before, okay? So this is repeat of what we have seen. So we change all of these y coordinates to a opposite of that. So -9, -4, -1, all of them change sign. And if you were to graph it, this is y equals x squared, and this flips over with respect to the x-axis. We have the same x coordinates, but the y coordinates. See, 1, 1 becomes 1 negative, 1, 2, 4 becomes 2 negative 4, and so forth. Domain doesn't change. In both cases, all real numbers. Range for the original one is 0 to infinity, but for the new one, for this one, is from negative infinity to 0. So the range does change. So when the right side of this function is multiplied by -1, the graph of the new function is the reflection about the x-axis. So this one gets reflected about the x-axis of the graph of the function y equals f of x. Let's look at f of x equals square root of minus x. And again, what I want to do, I want to show you these numbers. Because it's minus x, I have to have all negative numbers. 0 is the only one is okay. So -1 gives me 1. -4 gives me 2. -9 gives me +3, because like -16 gives you 16. Square root of 16 is 4. This gives you +5. This gives you +6. And so 0, 0, -1, 1, -4, 2. Those are the pairs. And if you look at this function versus these pairs that we have come up with, the reflection is with respect to the y-axis. So the domain, the range is the same, 0 to infinity in both cases. Domain for this guy is from 0 to infinity, okay? But for this guy is from negative infinity to 0. So the domain has changed for this function. When the graph of the function y equals f of x is known, the graph of the new function y equals f of negative x is the reflection about the y-axis of the graph of the function y equals f of x. So this time, reflection with respect to the y-axis. Let's combine them. Let's look at something a little bit more interesting. F of x equals square root of 1 minus x plus 2. So what I want to do, I want to show you two different methods in case. So you see how we approach them. You can do either one. Of course, we start with the basic function y equals square root of x. This, we should know the graph looks like that. The next one is to look at the function square root of x plus 1 by shifting it to the left by 1. Reflected WRT with respect to the y-axis. Y equals f of minus x is the graph of y equals f of x, reflected about the y-axis, because the point x comma y is replaced by the point minus x comma y. So we do that, and so we change this to minus x plus 1. You reflect it like so. Now, please understand minus x plus 1 under the radical, or 1 minus x under the radical are identical. In other words, this is by the reflection. We change the to minus x, but we know it means the same thing. And all you have to do, apply the plus 2 by moving it 2 units up. So the same thing, 2 units up. So now this 1, 1, 0 becomes 1, 2, 0, 1 becomes 0, 3. And there you have it. Just for the sake of argument, if they ask for the domain all the way from negative infinity to 1, and the range from 2 to infinity. I hope everybody can figure this out. Domain T. Range R. The y coordinate is 2 all the way to infinity, in case. Here's the second method, because some people may find the second method easier. Again, we start with the basic one. Y equals square root of x. Okay, so now I look at, I just follow this. I see minus x. I'm going to get minus x first, which means reflection with respect to the y-axis. So reflected with respect to the y-axis, y equals f of minus x is the graph of y equals f of x, reflected about the y-axis because the point x comma y is replaced by the point minus x comma y. So now this one becomes this one, which means you are changing the x, you're keeping the same y coordinate 1, this becomes negative 1, the same coordinate 2, y coordinate 2, this becomes negative 4. Of course, 0 doesn't change, 0, negative 0 the same. Now, 1 minus x, we are going to rewrite it as follows. So we can see these two are the same. So x minus 1, we can find x minus 1 and then negate that. So first and foremost, I want to get to x minus 1 and then minus of that. So to get to x minus 1, we are going to shift this to the right by 1 unit. Move 1 unit to the right. This is what you get. And you move it 1 unit to the right, okay, Same x coordinates become plus 1. So this becomes -3, this becomes 0, and 0, 0 becomes 1, 0. That's what you get. Now, so you replace the x by x minus 1, horizontal shift right by 1 unit. You can write it in this fashion, or by this fashion, minus x plus 1, or by this fashion. They all are the same. And finally, move it up by 2 units. So same thing gets shifted up by 2 units. And now you have the final answer. So everything here, you keep the same x coordinate, the y, this becomes 2, this becomes 3, this becomes 4, 2, 3. So that's how you do the transformation. I'm going to graph this function, and we start with the basic rational function y equals 1 over x, or the reciprocal function. We know here's the graph. We are doing it by the transformation. So this is the graph. Let's go with 3 over x. That means multiply by 3. That means the x coordinate doesn't change, but the y coordinate gets multiplied by 3. So this becomes 1 comma 3. This becomes 2 comma 3 halves. This becomes -1 comma -3. So you multiply the y coordinate by 3. Then replacing the x with x minus 2, that means shifted to the right by 2 units. So that means add 2 to the x coordinate. So this is 3, 3, this is 5, 3 halves, and this one, -1 plus 2 is +1, -3. So those 3 points. So it's really a good practice to have a few points, and you see the transformation. So we have this finally +1 shifted up by 1 unit. When we do that, all the y coordinates we need to add 1. So 3 comma 4, 4 comma 5 halves, 1 comma -2. So we shifted up by 1 unit, and it looks like that. So the effect is, of course, the vertical and horizontal asymptotes are different. Now we should recognize that. So, of course, y equals 2 is the vertical asymptote. Y equals 0, the x-axis was the horizontal asymptote. It's been shifted up by 1 unit. That's y equals 1. I'm going to find the equation of the function that is finally graphed after the following transformations are applied to y equals x squared. First and foremost, we're going to shift it to the right by 3 units, so it becomes x minus 3 squared. Reflected about the x-axis, you put a negative sign in front. Shift it down by 2 units, bring it down by 2 units. Add -2, in other words, -2. The graph of f of x is given. Draw the graph of the following functions. Y equals f of x minus 3, y equals f of x plus 1. So the best course of action is you have really 3 line segments. And for every line, you need just a couple of points. Okay, so you can pick 2 points, 3 points, whatever. So pick up some points and rewrite them. You always go with easy points. Obviously, this is -2, 2. This one is 1, 3. Just to, of course, I highly recommend you look at this one and this one also, and then you have your graph. But if I can do 1 or 2, I can do more. So y equals f of x minus 3. That means bring it down by 3 units. That means every y coordinate gets subtracted by 3. Okay, so move 3 units down. We are looking at f of x. How do you move it 3 units down? Every point, bring it down by 3 units. So if you look at this one, I'm going to subtract 3 from 2, I get -1. I'm going to subtract 3 from this one, and I get 0. Again, I'm leaving you to do a couple more on your own. I can't emphasize this enough. If I can show you work for 1 or 2, then you can do more points on your own. Okay? And the graph will look like this. This comes down by 3. Y equals f of x plus 1. That means we are going to move this to the left by 1 unit. So we move the same thing, move it this way by 1 unit. Move it this way by 1 unit. So all you have to do, keep all the y coordinates and change the x. So this one, you want to move it to the left, becomes -3. This one, you want to move it to the left, becomes 0. So -2, 2, this point now becomes -3, 2, and 1, 3, this point becomes 0, 3, and again and again. You can do more and more points. Just for the sake of argument, this is 0, 0. Becomes -1, 0. Again, this is what? 3, 2 becomes 2, 2. And that's the graph. All right. Y equals 1/2 x. So what do we do now? It's the same as graph of f of x, but has been shrunk by a factor of 2. That means in a vertical direction, we multiply by 1/2. That's the meaning of it. So every point, you keep the x coordinate, you multiply the y coordinate by 1/2, or you divide it by 2. Therefore, -2, 2 becomes -2, 1. 1, 3 becomes 1, 3/2. And 0, 0 doesn't change because, it's just 0 divided by any number. 2 or 5 or 10 makes no difference. Okay. So you're keeping the x coordinate, and the y coordinate you divide by 5. So this one by 2 divided by 2. So this 3, 2 becomes 3, 1. And it looks something like this. So it shrinks along the y-axis by this factor. So it gets smaller by a factor of 1/2, okay? How about y equals minus f of x? Okay, so we are going to reflect the graph of f about the x-axis. So it's important to understand that we are reflecting it about the x-axis because there's a negative here, right? So, which means if you're reflecting it with respect to the x-axis, you keep the x coordinate, but the y coordinate gets negated. This becomes -2, this becomes -3, 0, 0 doesn't change. 1, 3 becomes 1, -3, and so forth. This one is 3, 2 becomes 3, -2. So that's what happens. This is So again, just to make sure we understand that negative 2 comma 2, the y coordinate gets negated. 1 comma 3, the y coordinate gets negated. Dealing with an absolute value, reminding you that absolute value by definition means distance from zero. So absolute value of f of x is f of x, f of x is greater than or equal to zero, and minus f of x is f of x is less than zero. Absolute value of x equals a, that means x is plus minus a, assuming a is positive. If it's less than a, it's sandwiched between negative a and a, and it's larger than a, x is less than negative a or larger than positive a. I hope you remember that. The function looks like this, a V shape. Domain is all real numbers, range is 0 to infinity. Just to remind you, this is the definition of a absolute value, which is distance from zero. Determine the function obtained from a series of transformation. Of course, this is an absolute value function. Number one, shift left by 2 units. So absolute value of x plus 2. Shift up by 3 units. So we're going to shift up by, so this is the graph. 2 units to the left. So we have the blue one, 2 units to the left. I'm going to move this 3 units up. So we're going to add 3. And we are going to move this up by 3 units. So now it's this one, the green one. Finally, we want to reflect it about the y-axis, which means you are going to change the x to minus x. And so if you look at the green one with respect to the y-axis becomes the red one, and alternatively, f of x absolute value of minus x plus 2 plus 3. If you take the negative sign out and take it out, and it becomes absolute value of x minus 2 plus 3. In other words, this and this are the same due to the nature of an absolute value, whether you use minus x plus 2 or x minus 2. In an absolute value sign, it's the same thing. And under this is easier to understand. You're moving a 2 to the right, 3 up. So if you look at the blue one, 2 to the right and 3 up. It's easy to see. And all you have to look at the vertex located here originally. And now the new one. Located at what? This was 0, 0. This is located at 2, comma 3. 2, comma 3. Absolute value of a function, if y is absolute value of f of x, absolute value of f of x is f of x is f of x is greater than or equal to 0, and minus f of x is f of x is less than 0. And here's the definition of an absolute value. We want to sketch the graph of absolute value of x squared minus 25. So what is the process of graphing that? First, you graph it without the absolute value. Very simple. You know how to graph it. You know y equals x squared, bring it down by 25. So this has coordinates 0, negative 25. Then pay attention to this process. The part of the graph of f of x that lies above the x-axis remains the same. So this portion doesn't change. The part that lies below the x-axis is reflected about the x-axis. So this part, because it's below, flips over and looks like this. And now this is y equals absolute value of x squared minus 25. So pretty straightforward. Sketch the graph of the function y equals absolute value of square root of x minus 1. Well, first, let's just graph y, or f of x equals square root of x. So let's graph this function. Let's graph y equals square root of x minus 1, the one inside. So it means you are shifting this down by 1 unit. So take this down by 1 unit. Therefore, 0, 0 becomes 0, 0, 0 becomes 0, negative 1. One, 1 becomes 1, 0. Now, the portion, now we want to graph this. And I remind you, the part of the graph of f of x that lies above the x-axis remains unchanged. So this doesn't change. The part that lies below the x-axis is reflected about the x-axis. So this part, what color we can get? This part will flip over like that, and it becomes this. That's the final graph.